All right, so here's example 3, where we've now changed it from polar to coordinates to rectangular coordinates, and we've changed rectangular coordinates to polar coordinates. So we've gone backwards and forwards between there. Now let's go ahead and go from the different types of equations back and forth. So let's go here for this one. We're starting with a polar equation, which we talked about in 9.2, section 9.2, where we graphed that out and got like the rows or cardioid or limmason and all these different types. We're going to take that type and we're going to change it over to a rectangular equation. So we're going from the r's and thetas to x and y in the problem. So here with that, that's what we're going to deal with. So when we're done with it, that means we know that we're going to have nothing but x and y in the problems and no cosines or r's. So there should be no cosines or r's at the end of this problem. Okay, so let's start off with our formula here that they give, our equation that they give us. So we have 6 cosine theta. Now, with this, we have multiple pieces that we've learned already about what r equals, what cosine equals, and all that great stuff, and x and y equals. So I'm going to pull that off to the side here, so when we need it, we can pull it in. So first off, we know that r equals the square root of x squared plus y squared. We know that part for a fact. All right. Now, the other portions that we need is x equals r cosine theta and y equals r sine theta. And so what we're going to do is we're going to use that information to help us get from r's and thetas and cosines and all that great stuff to x and y's. So first off, before we do anything here, we know r is going to equal the square root of all of this. So we're going to do that in a few seconds. We're going to put that in there. But before we do that, on this side here, we have a 6 cosine theta. But when we talk about our x and y's, there's an r that must be there. It literally must have an r in there. So here, in order for us to be able to get an r on this side, we have to do something to both sides. So whatever you do to one side, you must do to the other side. So here, what we're going to do first off is we're going to multiply by r. Multiply both sides by r. So that this way we can have an r with the cosine here and kind of do something with our x. Makes sense. Cosines there. Only thing we're missing is r, so we can multiply both sides by r. As long as we do one thing to one side and do the same thing to the other side, it balances out the equation. So on this side, on the left side, we have r squared. This r times r is r squared. And then on the right side, we have 6r cosine theta. Hey, look at that. Look at that. We have r cosine right here, theta. And then we have r cosine theta. What? Wait a minute. So that means here we can go ahead and change that over to x because that's the same. That's what they both mean. They mean each other. So yeah, let's do this. So here we can go ahead and say 6x on this side. And then here on this side, we're going to deal with r squared for right now. We're not going to go fast with that part. So far, we changed that cosine over there and cosine theta over there to an x. We're good on that side. So that side's good. So let's look on the left side here and try to simplify that down and do something with that. And that's even easier because just think about it. R equals the square root of all of this. So if we just change r to that and keep r squared, it's going to be amazing. This is going to be wonderful. It's going to be beautiful. Beautiful, just beautiful. So r equals this. So for r, we're putting that in. Then I'm going to do quantity squared because that whole thing is being squared. And then we leave the other side by itself. Don't touch that. Don't touch that right side. Leave it as it is. Okay, and so now what do we know about square and the square root? Anybody? Crickets. Exactly. that means that we are going to have the square and the square root cancel out. They cancel each other. So we're left with just x squared plus y squared equals 6x. And then we're like, what do we do now? We're done. Now, this part will go into our conics portion later on when we get to that part. Or if we've already gotten to it, that part there, like the circles and the ellipses and all the great stuff, that's where this part's going to go into. So that's one of our conics type equations there. But it is still in rectangular form. So therefore, we're done. Bam! And again, when we get to our conics section, or if we've already got to our conics section, that's a conics formula right there. And if you look at it, it's really going to kind of be like maybe a circle, maybe ellipse, one of those things. Looks like more like a circle to me. But that's it. That's all example 3 is. Bam. So we just used our x, our y's, and what r is equal to change things over to x and y's instead of r's and thetas. So the last example we're going to do is we're going to change a rectangular to polar. And those are normally a little bit longer, but a little bit more work, but it's still going to be good though. All right, so here we go.